In 1.4, in your packet, this doesn't say more trinomial factoring. It says trinomial factoring part 2 in your packet. But on the check sheet and in your notes, I have it labeled as what it is on your check sheet, which is 1.4 more trinomial factoring. In my mind, it's still trinomial factoring, except it is the next level type of factoring. The people who wrote this worksheet are trying to give you more difficult problems. They're going to try to trick you in several different ways. They are going to add GCFs sometimes. They are going to add variables on both ends, so you're not going to deal with just x's or m's. They might throw in some y squareds involved. They might throw in some higher degrees in there, like a y to the 4th or an r to the 6th. All those are ways that they are going to try to trick you and make you think that this is different than what it was in 1.3. But you will not be fooled, because you are not easily fooled. You are smarter than the average bear. What we're going to do is we're going to follow the same concepts as we did in 1.3. The only differences are we're going to look for a GCF first if there is one. It's going to go in front of our final answer. We're still going to use guess and check and factor what is left. And then lastly, we are going to double check that it is completely factored. These two words are supposed to remind you that you may have to factor more than once. A lot of times it means you will have to factor more than once, and so on. So let's look at a few examples that we can do together. I'm going to start with number 2. And the way that we talked about it before is we said we're going to look for, normally you would go and jump right into the factoring thing, is what we talked about before. But what we're going to try this time is we're going to try factoring out a GCF first. Is there a GCF of all 3 terms? Always check that first. If there is, say what that GCF is out loud. If you factor out a 2, tell me what the first term is inside the parentheses. Go ahead and say it out loud. Perfect. Plus, what's the second term? Say it out loud. 30, just 31?
39.
Thank you. What's the last term going to be?
16.
Just the 16? Thank you. And when you get to this point, I wrote a little note for you because of the most common mistakes. If you factor out a GCF first, this goes in front of your final answer. We wrote that down because somehow students, when they pull out that GCF, it just disappears, and it's not supposed to. If you have 2 multiplying this quantity, then that 2 belongs right here. What I like to do is I like to just boop, boom, like that. So don't forget it. It doesn't go away. If you factor out a 2 in the front, it has to be there, otherwise it's not equal to the original quantity. Now, we're going to look at what's in parentheses, and we're going to see if we can break this apart further using a technique that we learned in 1.3 called guess and check. So I kind of don't even worry about the 2 since it's already in front. I'm going to look at the first term, and I'm going to split it up. And I know that 2n times n is going to be 2n squared. Because it's prime, and those are the only 2 possibilities, I pretty much know this is going to be a 2n and an n when I start this problem. 16, on the other hand, is going to be a little bit harder because it could be 16 times 1, or 8 times 2, or 4 times 4, or 2 times 8, or 1 times 16. I got all those different possibilities. But as I told you before, or last class when we were covering 1.3, I said you will be able to do this stuff in your head a whole lot faster than you could if you were to write down every single thing. So what I like to do is I like to take this one and multiply it to the first one, and then this one times that one, and I see what the two numbers are. In my head, what I do is I do 2n times 16, which is 32, and then n times 1, which is n. 32 and n. Will that make a 31 somehow? That works. I think we can make it work. Luckily for us, it's the first one. Let's see if it works. Let's try to get the 2n to times the 16. So I'm going to put the 16 over here. And I'm going to get the n times the 1, which is here. And what I'm checking, for anybody who's not following along, I am checking this product, which is 32n. Oh, what did I do? I'm sorry. This should not be an n. It should be a 1. 1. That works better. That looks better. 1n. What I'm checking is this product, 32n, and this product, which is n. And I'm trying to put those together to get to this 31. That would only work if this 32 was positive or negative. Let's go ahead and say it out loud.
Positive.
Which means your 16 should be positive. It would only work if this 1n was positive or negative. Say it out loud.
Negative.
Which means that this 1 should be a negative there. You should always FOIL to check. 2n times n is 2n squared. 2n times 16 is plus 32n. Negative 1 times n is negative n. Putting those together makes the plus 31n. And negative 1 times a positive 16 equals a negative 16. The last step that I actually have in your notes, we've guessed and checked it's worked. We should do this every single time. We should double check that our answer is completely factored. So I'm going to look. Is there another GCF in this parenthesis or another GCF in this parenthesis? No. Is this a difference of two squares? Is this a difference of two squares? No. You should check that because in this section, they are going to try to trick you by doing that. There's going to be some things that will factor further when we get to the next level stuff. Which brings us to number 5. Is there a GCF of number 5? What is it? If you were to factor out a 3, what would the first term be inside the parentheses? What would the second term be inside the parentheses? Just a 7m? What goes in front of it? Thank you. What's the third term going to be?
Plus 5.
Plus 5. What we are not going to do is we are not going to let this 3 disappear. That is the kind of mistake that is worth a -1 on your test. When I pass back your test today, you're going to see a lot of -1s. Those are the silly little mistakes that you make. Oh, you messed up on one little tiny thing. Anytime you get a -1 on a test, it's for something silly like this 3 just suddenly disappears. We're not going to forget about that 3. We're going to put it in front of our parentheses. We are all going to try to get as many points as possible and keep moving forward. Now that we have the 3's taken care of, we're going to try to factor out this stuff right here. I know how to break apart this 2m squared. I think it's going to be a 2m times m because this middle term has a single m in it. The good thing is that 5 is prime. It's either 5 times 1 or 1 times 5. But whatever we do, we need to get to this 7m somehow. So in your mind, you should be able to do 2m times the first number and the m times the second number and see in your head if it comes out to 7, or you should do the 2m times the 1 and the m times the 5 and see if that comes out to 7 somehow. And hopefully you know which one goes where. I see it. I hope you do. I'm going to ask you, what goes right here? If you know it, say it out loud. Somebody even said positive. I'll put the positive there. What goes right here? Now let's just check. Outside is 2m. Inside is 5m. 2m and 5m adds to be 7m. And positive 5 times a positive 1 equals 5. We made sure that our GCF is still in front. And then what we should always do is there any more GCFs inside this parenthesis? Is there any more GCFs inside this parenthesis? Is there a difference of squares? Can it factor further? If not, then we're done. How are they going to try to trick you further? They're going to throw in some y squareds. Uh-oh, y squareds on number 6? It's okay. It is not as hard as you think. The good news is that is there a GCF of all 3 terms? There is no GCF this time. We're just checking. There is no GCF. Then what we'll do is we're going to break apart, since it's a trinomial, we're going to break this apart into x times x. There's a 5xy. The reason for that xy is because we need to split this apart. When you're splitting apart 14y squared, you should be thinking it's 14y times another y. That makes 14y squared. Or 7y times 2y, that makes 14y squared. Or 2y times 7y, that makes 14y squared. Or 1y times 14y. Those are our possibilities. Hang on a second. If you're trying to imagine in your head what comes out to be a 5xy, when you do an x times this, you're going to get like a 14xy, and this other one is going to be another xy. In my mind, that makes 15xy. I can already tell it can't be this top one. I've already eliminated that by doing that in my head. I can see that this would be 7xy and a 2xy. Is there a way to get to 5xy from that? So somehow we're going to use this one or this one, believe it or not, because there's still a 2xy and a 7xy. I'm going to put the x's in the front. I'm going to put the 7y and the 2y like this. And what we really need to figure out is what are the signs that are going to be here. I have a 2xy and a 7xy. I want to have 5xy left over when I put those together. Is the 7y going to be positive or negative? If you know, tell the person you're sitting next to. For everyone who said positive, you were correct. If the 2y is going to be positive or negative, say it out loud.
Negative.
It has to be negative. It's the only way to get a positive 7xy and a negative 2xy. When you put those together, you're going to get a positive 5xy and you're going to get a negative 14y squared when you multiply it out. I'm hoping that makes sense to you. And then you look at that, and a problem that looked a little intimidating at first, not so hard. Not so hard at all. Is there any GCFs? I should check. Is there any difference of squares? I should check that. If not, there's our final answer for number 6. You can always double check by foiling. You should be able to get that same answer, by the way. That's why we're doing the guess and check method. Then what they do, number 13, is they try to trick you by doing something to the 4th power. So these kids will get fooled if we go to the 4th power, but not the honors 2 students in this class. You are too smart for that. You're going to look at this middle term and see what variable they have, and you're going to kind of know that you're not going to use y to the 3rd times y here. You're going to split this up into something that makes sense for that middle term, like y squared times y squared. It has to be. You would never use y to the 3rd times y here because that middle term is a y squared. We automatically know what should be in the front of these 2 parentheses. I should backtrack a little bit. Step number 1, I'm supposed to check for a GCF. I don't see a y in the 20. I cannot factor out a y. I cannot factor out y squared because there's not a y squared in the 20. There is no GCF of number 13. So then I break that apart. The 20, I have a couple different options. 20 times 1, 10 times 2, 5 times 4, 4 times 5, 2 times 10, 1 times 20. Lots of different choices here. And what we need to do is figure out which ones are going to add together to get to 9y squared. In your head, you can probably eliminate 20 and 1, 10 and 2, that makes 8 or 12, 5 and 4, ooh, how about that one? You guys are going to get real good at that. Positive 5 or negative 5? Say it out loud.
Positive.
Positive 4 or negative 4? Say it out loud. We should double check. Y to the 4th, 4y squared and 5y squared makes 9y squared, and positive 5 times positive 4 is a positive 20. It works. But then what we should do is we should check, can I factor this further? Can I factor this further? Is this the difference of 2 squares? This is the sum of 2 squares. The difference means it has to have a subtraction sign. If it doesn't have a subtraction sign, you cannot factor it further. So there's your final answer. And then you realize you understand this stuff, and it's not as hard as you think. Last example, then we'll be done with these notes, is number 15. I bet you could factor this left side pretty easily. You're going to split this up into what times what? So tell your partner if you know. I heard several people say r to the 3rd or r cubed. Same thing. Now what we got to do is break up the 3, and nice, because it's only either 3 times 1 or 1 times 3. I'm going to put the 3 and the 1 here, and then I'm going to show you something. We need to get to negative 4. This one gets overlooked all the time, so I want you to see it. If you do this and put a negative and a negative, that will work for your O being a negative r to the third, and that will work for your I to be a negative 3r cubed. These together will make this term right there. But what about the last times the last in FOIL? What does a negative 3 times a negative 1 make? Does that make this negative 3? Whenever it doesn't make that thing, it means your factors are incorrect or you need to try different signs. But if you were to change this to a positive and this to a negative, then these would not add to be to negative 4. You can play around with this one as much as you want to, but number 15 is the only prime on 1.4's worksheet. Prime means you can't factor it. Prime means this does not work. You cannot turn this into multiplication. And I say that to you because I'm not really sure if they meant to do that when they made this or if it's a typo. But maybe it's good for us to just talk about it and say there are times where you're not going to be able to factor it. But I don't want you to think that the other ones are not factorable because you can. This is the only one that is prime. We're going to stop your notes right there.